Okay, guys, today we're moving into a different unit. I know we probably need some more practice in the inequalities unit, but unfortunately, we've got to keep moving to make sure that we get a look at everything that we're going to need to see this year, even though we clearly didn't go into depth this fourth marking period. All right, so something we didn't get to do in the fourth marking period was the powers test. But I wanted you to start thinking about your perfect squares. And when we're thinking and we're almost automatic with our perfect squares, this unit is going to become very easy. If we never really truly memorized our perfect squares, then this unit could become frustrating. Okay, so I'm going to fill in this table. We know what most of these are. 1 squared is 1. If 1 to any power is always going to be 1, but we're going to be focusing on squares in this unit. 2 squared is going to give us 4. 3 squared is going to give us 9. 4 squared, 16. 5 squared, 25. 36. 49. 64. 81. Okay. 100. 121. 144. 169. 196 and 225. Now, I asked you to go all the way up to 25. You should review those facts, but we're actually going to be reversing the order of things now. Since we know that 2 squared is going to be 4, then we're going to say the square root of 4 is going to be 2. And the square root of 1 is 1. Since 3 squared is 9, the square root of 9 is going to be 3. Since 4 squared is 16, the square root of 16 will be 4. And 5 squared. Okay, so squaring and square root are inverse functions. Okay, so when you square something, the opposite of squaring that, it would be to square root. And that's what this symbol is. This is a square root radical. Looks kind of like a division sign, except for this little funky thing in front. Let me draw that a little bit better. Okay, so the square root radical symbol right here. Anything underneath the radical is referred to as the radicand. So 6 squared would be 36. If 36 was my radicand, if I did the square root of 36, my answer would be 6. And you get the idea all the way out here. Square root of 49 is going to be 7. Square root of 64 will be 8. Square root of 81, 9. And the square root of 110. I'm going to stop there, but you get the idea. Okay, so the square root of 121, 11. Square root of 144, 12. Square root of 169, 13, 14, and 15. So we need to be able to think either way of squaring a value or square rooting it. We're going to be, we need to know our squares so that we can do the next phase of this, which is going to be square rooting. Okay, so if we take a look here, there's going to be a little exercise in estimating. Let me erase that. If we want to estimate, and this is a skill you should have, but it's not what we're going to focus on. If I wanted to estimate about what the square root of 78 would be, I'd want to find the perfect square roots on either side. So I know 78 is a little bit less than 81, and it's a little bit more than 64. So if the square root of 81 is 9 and the square root of 64 is 8, then I know the square root of 78 is going to fall somewhere in between those two values. Now, this is an exercise which we can take a look at another time, but with us running out of time in the school year, I'm going to bypass this for now. Okay, so we're going to skip the exercises on decimal estimation, and we're going to get into something that we're going to call simplest radical form. Now, simplest radical form is you're going to be using a lot throughout the rest of your high school career. So it's a skill we should become very proficient at when you guys go into geometry next year. You'll be using a lot of square root radicals, especially once you do the Pythagorean theorem. Okay. So simplest radical form means we are going to take any perfect square factors out from underneath a radical sign. Okay. And once we take it out, we take the square root of it and it stays as the coefficient of the radical. Okay. I know this seems a little bit weird right now, but bear with me. It's not as bad as it sounds. What we're saying is if the number underneath the radical, we can't take a perfect square. We would get some kind of weird, funky decimal. Well, if we looked at the number inside, that number could be the product of a couple different things. And radicals, anything that's underneath a radical, can multiply. Okay, they're both irrational values. But if one of them's a perfect square, then one of those irrational values can come out, become rational, and sit as the coefficient in front. So let's walk through a quick example here. So if we had the square root of 20, the square root of 20, we know it's less than 25. Okay. The square root of 20 is less than 25, but it's greater than 16. Okay. The square root of 16, we can take perfectly. It's 4. The square root of 25, we can take perfectly. It's 5. So the square root of 20's value is going to fall somewhere between 4 and 5. Okay. But what we're going to do here is we're going to simplify this. We're going to say inside here, 20 although it's not a perfect square, it has perfect square factors. So when we break up 20, what we're going to try to do is see, is it divisible by any of our perfect squares? Okay. So my perfect squares that I'm going to think of with 20, well, 1, I don't have to worry about. It wouldn't change anything. So I'm really thinking 4, 9, 16. I don't have to worry about 25 because 25 is larger than this. So really, these are my only perfect squares that are less than this value. So I want to see if I can break this up. Is 20 divisible by any of these three? And it happens to be. It is divisible by 4. So what we're going to do is break 20 into the square root of 4 times the square root of 5. The square root of 4 we can take. It's going to become rational. And once we take the square root of 4, the answer will be 2. So once you do that, the radical goes away, and now you have a constant that's going to sit as the coefficient on the outside of this radical. The square root of 5 we can't take. It's not a perfect square. It's actually trapped between 4 and 9 and wouldn't be divisible by either of those. So it's actually a prime number. You can't break it up any further. So the simplest radical form of square root of 20 would be 2 times the square root of 5. Okay, 2 times the square root of 5. All right, now let me take a look at some practice problems here, and I'll walk through some of them with you. Here, we would be thinking, all right, what values or what perfect squares I'm going to list until I'm higher than that. So again, we don't list 1. It's dividing 1 by 1 would just give you itself, so it wouldn't get you anywhere. So 4, 9, and 16 I would consider here because they're all less than 18. Now, it is not divisible by 4, but it is divisible by 9. So I'm going to write this as 18 is the same, or the square root of 18 is the same as the square root of 9 times the square root of 2. Okay? The square root of 9, we know. We can take it. The square root of 9 is going to be 3, but the square root of 2 we don't know. So the simplest radical form is going to be written as 3, the rational number 3, times the irrational number square root of 2. Okay, now 80, we're going to think to ourselves, okay, what is it divisible by? But more important, we want to know what perfect squares are divisible by. So we've got 4, 9, 16, 25. Actually, 36 is less than that. I usually stop at the halfway mark, okay, because if it was divisible by 2, so I'm going to write 49, but I really don't need to use that. And like 64 just wouldn't divide in there evenly either. So we can see that 80 is going to be divisible by 4, and we could start there. But we could go a little further. Is it divisible by 4? Is it divisible by 16? It does happen to be divisible by 16. 16, or so the square root of 80 can be written as the square root of 16 times the square root of 5. Okay, I'm going to do this once again. If I started with a 4, to show that you still end up at the same result. So this is the largest perfect square that 80 is evenly divisible by. And the square root of 16 is going to give me a 4. Okay, and that becomes rational. So I have the rational number 4 times the irrational number 5, and this is going to be simplest radical form. If I broke 80 up and said, hey, I'll start with 80 is the same as the square root of 4 times the square root of 20. It does work, but then what we'd have to notice here is 20 is also divisible by 4, so it would have to be broken up again. So 20 is the square root of 4 times the square root of 5. And now, square root of 5 I can't take, but the square root of 4 I can. And the square root of 4 I can. Square root of 4 is going to be 2 times the square root of 4 is also 2 times the square root of 5. And then the 2 times the 2, both of these are rational numbers, so rational numbers can multiply by each other. Rational numbers cannot multiply by irrational numbers, so that's why we're going to leave it in simplest radical form. You can see we end up at the same place, but if you try to find the bigger factors first, you get there a lot quicker. Okay, taking a look at 98. 98, I actually kind of see here, rather than testing all these numbers, I know it's not divisible by 4. It doesn't follow our rules of nines. 16, it wouldn't go in. If it's not divisible by 4, it's not going to be divisible by 16. Clearly not divisible by 25. 36 wouldn't work, so I'm going to start with 49. And sometimes you can actually work just by your divisibility rules. It's not probably the best way to start by like just dividing by 2, but sometimes dividing 98 by 2 to see that what is left is 49 is one way to get things started. I prefer, though, to divide by my perfect squares since I was memorizing them all year. Okay, so square root of 98 can be broken up into the square root of 49 times the square root of 2. Square root of 49 is something that would be rational. Square root of 49 would be 7. So that becomes the rational number 7. But 2, we can't take the square root of, so it stays underneath the radical. So 7 times the square root of 2 would be simplest radical form. Over here with 200, well, I'm looking at the double zeros at the end, and I already know that that's going to be divisible by the perfect square 100. Okay, square root of 100 by the square root of 2. Square root of 100 I can take. That will be 10. Square root of 2 I cannot, so it stays underneath the radical. Okay, so simplest radical form is 10 square root 2. Down here, 63, well, that clearly follows our divisibility rules of 9, so I'm going to start there. Square root of 9 times the square root of 7 is the same as square root of 63. Square root of 9 we can take. That'll give us a 3. Square root of 7 we cannot, so it stays underneath the radical. So you have the rational 3 times the irrational root 7. So 3 square root 7 would be your solution. Now this year, we're probably going to get comfortable just saying 3 root 7 or 7 root 2 or 3 root 2. But realize when you get into algebra 2, these radicals are going to change. So something that's not written that is implied and actually could be there is the index, which is 2. This is a square root radical symbol. When you get into algebra 2, you get things like a cube root or a fourth root. So these are things that we don't have to worry about this year, but they're coming. As we grow in mathematics, we get better, we're going to learn new and different things. Okay, here is square root of 288. Okay, I know my tables, so I'm going to break that up into square root of 144 times the square root of 2. Okay. Now, I could have gone through my rules of realizing that, hey, this is going to be divisible by 4. It's divisible by 4 again. And it's also divisible by 9. So as a result, it's going to be divisible by 144. Okay, so 144, the square root is going to be 12. Okay, that becomes rational. The radical goes away. The square root of 2 we can't take, so it stays underneath the radical. Okay, so 12 square root 2 would be simplest radical form. Okay. All right, guys. We're going to start today doing just this skill. I'm going to have a Zoom conference call today with some of you guys. So we'll go over some of this, and I'll also have an extra help session to help you guys with the absolute value inequalities. Okay, guys. So E1 IXL is going to be your assignment for today.